Okay, good afternoon. I'm just getting started on the review for the Geometry Section 13 test. So this one is looking for A. So A is this little letter right here. And in my class we draw this as an ice cream cone. So this is the cone and this is the ice cream. And this is the tip of the cone. So our tip of the cone, or our inscribed angle, is 1/2 of 75. So that's 37.5. For B, we're looking at this angle here, this inscribed angle, but we don't know what this inscribed angle is. We need to first find the measure of this arc C. So we would take 84 and add it to 100, that's 184, and we would subtract 184 from 360, which means that C is 176, which means this is again the cone on our ice cream. This one's a little bit more snow cone-like. So B would be 1/2 of 176, so 88. Alright, so we already found C, that's 176. D is, so this is clearly marked as a right angle. This is the center of the circle, so D matches the central angle. The central angle is 90, so D equals 90. And then F is down here. Looks like F, so F is just the remainder of the 360, so if this is 101, oh, you have to look carefully, so this is 56, so if this is 56 in here, this is my inscribed angle, this is my snow cone, this is my ice cream. So if this is 56, then out here is going to be 2 times 56, so that would be 112. So I need to add 112. I can show you. So we have 56 times 2, that gives us the ice cream, that's 112, plus 101. So we have 213, and we need to take 360 and minus 213, and we get 147. So F equals 147. Okay. And you can always check your work. You can make sure that 147, 101, and 112 equal 360. So 147, let's put this over here, plus 112 plus 101 equals 360. So I did it right. Okay. What is the measure of RT? So RT, that's the arc measure of RT in the figure, oops, to the left. Just kidding. There we go, left. RT. So we have, we can see that this is 40, and we have a rectangle inscribed in our circle. So there are a couple ways of doing this. You can see that if I were to split my rectangle in half, that if this is 40, then this must be the remainder of 180, so this must be 140. That's pretty much it. You can also see this, you can, if you are dividing this in half, right, you can see that this would be 2 triangles, okay? And you can also use the inscribed angle. But this is a 140, because 40 and 140 equal 180. Okay. Given the following diagram, answer the questions below. So the diagram's off to the right here, and it says what is the value of x. So I need to figure out what x is. All right, and so I have a couple options. The easiest way of doing this is you can either set them all equal to 360, so you know that, let's see, so this arc plus this arc, which is that measure, plus this arc, which is this measure, equals 360. So I'm just going to put that here for more room. 4x minus 6 plus 8x plus 6 plus 8x equals 360. Positive 6 and negative 6 cancel out. We have 4x, 8x, and 8x. 8x and 8x is 16x. 16 and 4 is 20. X equals 360. So we can divide both by 20, And you can show your calculator. 360 divided by 20 is 18. So x is 18. X is 18. Okay. So if we know that x is 18, then I can plug x back into all of these and figure out, they want me to see, let's see, what is the measure of arc PQ? So PQ is this arc here, the arc measure. So I'm going to need to plug it in. So 4 times 18 minus 6, so 66 degrees. And then what type of triangle? Okay, so if this is 66, I'm going to just go ahead and figure out what the rest of these sides are, so I know more about my triangle. So if this is 66 out here, I know this is a 33, right? In here, because this is the ice cream to my cone. Okay. And then I can go 8 times 18 plus 6, that's 150, so this is 150 onto this cone, so that would make this 75, and then I can go 8 times 18, or I could have subtracted all from 180, doesn't matter, so 8 times 18 is 144, so this is 144 out here. Divide that by 2 and we get 72. Okay. So what kind of a triangle is this? All three angles are different, so that means that I have a scalene. And that's it. Consider the circle below. I think that means the circle to the left, right here. So this is my diagram. What is the measure of x, z, y in degrees? So x, z, y, I'm looking for, just make sure I looked at it right, x, oh whoops, x, z, y. Okay, well, there's a little dot here indicating that this is a circle, the center of my circle. That makes this a semicircle. Any angle, any inscribed angle in a semicircle is a 90-degree angle. So this is 90 degrees, which allows me to solve for x, which means I set 24x minus 54 equal to 90. Add 54 to both sides. 24x equals 144. So x goes into 144. So 144 divided by 24. So we know that goes in 6 times, but I can show you 144 divided by 24 equals 6. Okay, x equals 6. Good. Consider BMX to the right. This is not drawn to scale. So by, let's see, so I know by, I'm going to need to use, whoops, the tangent segments theorem. So if this is 3.2, I know this is also 3.2, just this little chunk right here, which means I can figure out what this chunk is, because I can subtract 3.2 from 15.2, right? And I get 12. So this is 12. And then if this is 12 here, this is also 12. And if this is 12, then I can figure out what this piece is here. So this is 18.5 minus 12, which equals 16.5. So this is 16.5, which means this is 16.5. Okay. So b to x, the whole distance, would be 16.5 plus 3.2, which is 19.7. Okay. And let's see. Oops, actually I made a mistake. Oh, it's not. Oops. Let's try this again. Okay. So it's not, whoops, 18.5 minus 12 is not 16.5, it's just 6.5. All right, there we go. So this is 6.5. Just 6.5, which means this is just 6.5. There we go. So the length of b to x is 6.5 plus 3.2. Okay, so that's 9.7. 9.7. Can't be perfect. All right. What is the perimeter of the whole thing? So if this is 9.7 here, This one was 15.2, and this is 18.5. We can add them all together. 9.7 plus 18.5 plus 15.2 is 43.4. Yep. All right. 43.4. Okay. Consider the diagram to the left. Find the values of x and y. Okay. Well, we know if we have a quadrilateral inscribed in a circle that opposite angles equal 180. So that'll allow us to solve for x. We have to solve this one first because this only has an x. This one has an x and a y. So we'll start with solving for x. So 7x plus 4 plus 120 equals, so it's supplementary, so 180. And so make sure I wrote that down right. Yep. So this is 7x plus 124 equals 180. So we have to subtract 124, subtract 124, and we get 56 is equal to 7x, so x equals 8. X equals 8. And now we need to figure out what y equals. So if you look here, this is 4x plus 21y plus 85 equals 180. We know what x is equal to, so x goes plugged in here, so that's 4 times 8 is 32 plus 21y plus 85 equals 180. And so I'm going to combine 32 and 85. So we have 107. Let's try this. 117. 85 plus 32 is 117. So we have 21y plus 117 equals 180. I have to subtract 117 minus 117, and we get 21y equals, so 180 minus 117, right? 63. So y equals 3. The diagram shows a circle with a center P, so we're here. A diagram BD and, a diagram shows a circle with a center of P, a diameter of BD, so they're telling us the diameter, and an inscribed triangle BCD. Okay, this is the diameter. We know that BCD is a 90-degree angle because that means that this is a semicircle. Given that PC equals 8, let's see BD, so this angle here equal x, our inscribed angle, and the measure of BCD, so our 90-degree angle is x plus 62. Find the value of x. That's easy. So we know this is 90. So 90 equals x plus 62. So subtract 62. So x is equal to 28. So x is equal to 28 degrees. So that means this is 28 degrees. And the length of CD is what? Okay, so if this is the radius, we know that this is 8. And we also know that this then therefore has to be 8. So my question is here, so the length of CD, so they want to know the length of this. Well, the only way to know the length of this, or to understand if it's 8, less than 8, greater than 8, is to know what this angle is here. Okay? So what is this angle here? So if this is, we found this to be 28 degrees, and we know this one is 90 degrees here. Okay, what is this degrees here is what I'm wondering. So we can, let's see. So, alright, if this is 28 back here, that's my inscribed angle. I know that this arc here is going to be 2 times 28, so that's 56. So if that's 56, this is also 56 because this is a central angle. So if this is 56, and this is 8, and this is 8, I know that this is going to be smaller or shorter than 8 because this is not a 60-degree angle. This is less than 60 degrees. So coming back to our triangles and knowing our rules about if it was equilateral triangle, right, then all sides, if this was 8, 8, and 8, we know that this would have to be 60, 60, and 60 because it would have to be 180. Because it's not 60, 60, and 60, because it's less than a 60, then we know this has to be less than 8. Okay, so this is less than 8 because the measure of CPD is less than 60 degrees. Okay. Alexa uses her compass to evenly divide the circumference of the circle below. Which regular polygons can be constructed from the construction? So first we have to count how many marks. So I'm just going to mark the one I'm starting on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, nope, 12 marks. So there are 12. And so if we drew in, right, each one, every single one, then we know that we would have a 12-sided figure, and we want it, it's a regular polygon, so that means that each side and each angle are equivalent or congruent. So that would be a dodecagon. And then we want to look for things that are evenly divisible into 12. So the next one it could possibly be, so if we skipped one every time, then that means we would have a 6-sided. So if it was 6-sided, we would have a hexagon, because 6 goes into 12, so that's a hexagon. 4 also goes into 12, so that could be a square. And then 3 also goes into 12, which means it could be an equilateral triangle. Okay. Consider the circle on the right where RHE equals 32. So RHE, they already marked it for us, is 32, and EK, the measure of this arc here, is 48. Okay. Determine RSK, so that's that whole thing here. So we just need to know what this whole, if this is what we're looking for, that's the tip of our ice cream cone, we just need to know the whole ice cream. And we can know that by, if this is 48, we only need to solve for this. So this is 32, this is double of 32, so that's 64. 64 and 48, right? We have to add those together. So 64 plus 48, 112. 112 divided by 2 is 56. So this is 56 degrees. Right? And then we're looking for RS. Oh, we found that. That's RSK. Oh, oops. Sorry, 56, and ER was 64. Okay. Back on the page. There we go. Roberto is designing a logo for his coffee shop according to the design below, where each chord is equal in length. What is the measure of each arc in degrees? So they're asking for what is each arc, which means what is this measure, or this measure, this measure, this measure. So we don't really need the 6 feet yet. We know that this is a square, and if that's a square, then we know that our 360 is divided by 4, which means that these are all 90-degree angles, which means that this is 90 degrees, which means the arc is also 90 degrees because this is the center, and central angle equals arc measure, so 90 degrees. What is the approximate length of each chord? Okay, and the chords are, I'll show you in a different color. This is the chord here, chord, chord, chord. So there are 2 ways of doing this. You can either remember we have a 45, 45, 90, or so we're looking for the chord. This is the green part here. Okay, or you can also, we know that this is 3 and this is 3, so you can also use the Pythagorean theorem. So, or you could just know that this is 3 square root 2. Either one. But they do, so, or 3 squared plus 3 squared equals, our chord squared, c squared, so that's 9 plus 9 equals c squared, that's 18 equals c squared, and then you just plug it in your calculator, square root of 18 equals 4.24. Approximate length. They didn't tell us what to round to. I'm going to say 4.24. Maybe on the test it'll be an even number. In the circle to the left, determine the value of x and y. Okay, so looking for x and y, and then we're looking for the measure of d and y. So what we need to look at is we know that if we have an arc in a circle and we have two inscribed angles with the same intercepted arc, these two angles, so we're going to have an intercepted arc, we have an angle here and an angle here, we know that these angles must be congruent. So this is congruent to this. So they also have the same variable, which means that we can solve for that variable. So we go 4y plus 2 is equal to 2y plus 14. Subtract 2y. We get 2y. And subtract 2 at the same time. And I'm going to have equals 12, so y equals 6. And then we have, we need x, so that would mean, and so it's the same thing, or same idea. We have an intercepted arc, and we have our two inscribed angles on the same intercepted arc, which means that these are also congruent. So I can set those equal to each other. So 2x plus 2 has to be equal to 4x minus 16. I'm going to subtract 2x minus 2x. I'm going to add 16, I get 18 is equal to 2x, so x equals 9. Determine the measure of d and y. So d and y. So I'm looking for this measure right here. And let's see. There are a couple different ways of solving this. I'm going to, let's see, I think I'll solve, if I want to know this, I think I'm going to solve for one of these angles, and then just know that that's supplementary. So I'm going to solve for this angle right here. So 4y plus 2, that's 4 times 6, so 4 times 6 is 24, plus 2 is 26 degrees. This would be 2 times 6, so 12, oh no, I looked at the wrong one, sorry, 2 times x, so that would be 18 plus 2 equals 20. So this is 20 and this is 26, the remainder from 180, so I can show you guys. So that's just going to be 46, so 20 plus 26 equals 46. Subtract it from 180 and I get 134. So this angle here is 134 right here, which means that its supplement, right, has to be 134 less 180. So 180 minus 134. So 46. So this angle here is 46. The circles below, I think this means to the right, this one right here, are concentric. Sorry, the circles below are concentric. This should say circles to the right are concentric. What is the measure of the angle formed by the two secants? So these are secant lines because they touch or they cross through the circle in 2 points. So this is a secant line because point and point. And this is so we're looking for this arc right here, this one. So how do we find this? Well, this is in topic 8 of section 13, and although it's not super explicit in the topic, the way you find the arc, so this measure here is going to be, you take, so you're just going to look at the outer circle first. I know this is kind of hard because it overlays two circles, but you're going to look at, you're going to pretend like this is just one circle. So the purple circle, or the purple circle is going to be my outside circle. So we're going to look at that first. So the way to calculate the arc, or sorry, the way to calculate the angle formed by these two secants, this one and this one, is by taking the measure of one of the arcs and subtracting the measure of the other arc. and then dividing by 2. So it's 91 minus 43 divided by 2, and that equals this measure here, so the measure of the angle. So we'll just use calculator. 91 minus 43 divided by 2 is 24. So 24 is the measure of this, 24 degrees is this angle right here. It's supposed to look like an arrow. Okay. And then it says what's the value of x. So we can work backwards this time, and we can say that this arc, this big green arc here, minus this arc equals, again, the angle formed by the two secants. So same secants, but now we're talking about the inner circle, this green circle. So what you're going to do is you would do x minus 68 divided by 2 is equal to, we already found this in the previous step, 24. So multiply both sides by 2, we get x minus 68 equals, that looks like 0.2, so equals 48, and then we're going to add 68, so x is equal to 116, okay? And that's pretty much all you do for that. So this is 116. Okay, consider the diagram. Oh goodness, this one's to the left. I've moved a lot of these pictures around. So we're looking at this one here, and this problem here, number 13, comes from, and I'll just show you, section 13, topic 6, and it's based on the intersecting chords theorem. So where we say that BT times AT, so this section times the length of this section is equal to this section times the length of this section. So again, the intersecting chords theorem. So again, you have two circles that are sort of on top of each other, which makes this a hard problem just to see visually. So I sort of recommend making two circles. You can do the inner circle first. So that's going to be this circle. The green, I'll do it in green. So this one's split, doesn't have to look exact. So they say that this distance is 8. This one's 3. We don't know this here. And this is 4. So like I just showed you in the workbook, so this would be 8 times 3 equals 4 times x. So 24 is equal to 4x. So x equals 6. And that's all you have to do. And then we have the other circles, the outer circle. I'm going to do that one in purple. The outer circle. And I think honestly it's just easiest to redraw it. So I'm going to do the purple circle. Again, looks like this. And we can now fill in our missing information. So we now know that this here is 6. So this distance is 6 plus 1 is 7. This is 4 plus 4, that's 8. And then this distance is 8 plus y. We don't know that. And then the top distance is 6. Okay? So, and this question is asking for what y is. So we can essentially find the whole distance and then subtract 8. So I'm going to look for x. I'm going to look for this whole distance. So it's just 7 times 8 is equal to 6 times x. So 56 is equal to 6x. And let's see. Maybe not so pretty, huh? So we're going to divide both by 6. So, and I shouldn't have used x, realizing because I've already used x up here, but oh well. We're just looking for this distance. So this x is equal to 56 divided by 6, which is 9.333. So it means this whole distance here is 9.3, which means that y here is just 9.3 minus 8, which is 1.3. 1.3. And you could have also, we could have just left this, we could have done this in a decimal. So we could have said, let's see, 25, 26.8, so we could have done, let's see, we could have said 28 over 3. Could have done that also, reduced it down, but not much you can do. And then you could have kept it in a fraction. It's okay, y equals 1.3 is just fine. So we want SQ, we want the whole distance, so we already figured that out, because that was 1 plus 6 plus 4 plus 4. So again, that was 8 and 7, which we already found before. So that was 15. That was easy enough. And then PR, so PR is 3 plus 3 plus 9.3. So we're just going to get 15.3. Repeating, because it was 3, 3, 3, 3, 3, right? Okay. A broken piece of pottery found at an archaeological site is shown to the left. I'll fix these in my review that I post on OneView and in Focus. If QS lies on, so QS lies on the diameter, okay, so this is kind of a bad picture, it didn't copy very well, but what you're seeing here is this is the diameter circle, so the radius is somewhere down here, right, and this looks like this, so this is the center. A broken piece of pottery found at an archaeological site is shown to the left. If QS, so QS lies in the diameter of the circle, what is the circumference of the original pottery found to the nearest tenth? Radius of the circle. Okay, radius of the circle and the circumference of the circle. Okay, so we want the radius of the circle. There are two ways of solving this. There's the method we just used above, or there's also the method that we used in the book, the tangent, that we have a chord and we have a diameter that bisects the chord, and then these are congruent, and then we can solve for radius like that, essentially making this into a right triangle. So I'll show just as, let's see, I guess I'll show the faster way, which is if I'm looking for this whole distance here, and I have this distance and I have this distance, so I have 7 times 7, so 7 times 7 is equal to, this distance is 4, so I'm looking at it like this, 4 times, I don't know, so essentially it's our question mark. We can call it, can I call it S? I can call it S. Nope, that would be bad. Let's see, let's call it X. So 49 is equal to 4X, so X is equal to 49 divided by 4. So we have 12.25. So this distance is 12.25. Okay, so the whole, if the diameter, I guess I could have called it D, is 12. If this is 12.25, then my diameter is equal to 12.25 plus the little part up here, plus 4. So the diameter is equal to 16.25. Which means that the radius would be half of that, so the radius is equal to, let's see, divided by 2 is 8.125. Okay? Again, you could have solved this another way too. So, okay. And so if the radius is that, we want it says radius of the circle is 8.125. It says, round to the nearest tenth, so 8.1, okay, and centimeters. And then the circumference is equal to 2 pi r, so 2 pi times 8 point, I'll just do 8.1, so 8.1 times pi times 2, so 50 point, we'll call this 50 point, let's see, round to the nearest tenth. Okay, so 50.9 centimeters. So I just want to show the other way of solving the problem, because that's how a lot of my students will probably solve it or think about solving it, because it's what we practice on our worksheets and our workbook. So I just redrew the picture. Again, this is the center of the circle, and we have a chord that's been bisected by a diameter. This is 7 and 7. This is 4. That's what I told you. So I know if I draw a line from the center to the edge of the circle, that I have a radius. Okay, and so now I have a right triangle, because this is a right angle, that has, this distance is 7, this distance is r, and the question is, what is this distance here? Well, this distance is r, and this is 4, so this distance is r minus 4. And then you can use the Pythagorean theorem to solve. So this is definitely the harder way of doing the problem, but again, some people are more familiar with this. So I'm going to call this our a squared plus r minus 4 squared, and that's equal to my hypotenuse squared, radius squared. So 49 plus, and then I have to multiply this out. This is r minus 4 equals r squared. This is 49 plus first, so r squared minus 4r inside minus 4r last plus 16 equals r squared. And then we have, we combine like terms, so 49 plus r squared minus 8r plus 16 equals r squared. R squareds cancel out. The 49 and the 16 combine, so I get 64 minus 8r is equal to 0. Add the 8r, add 8r over here. So I get 8r is equal to 64. So the radius is equal to 8, which is close to what I got before. So due to rounding issues, not even rounding issues, due to the method in which we solved it, we get a whole number when we solve it using the radius, or the chord bisecting, where we get a decimal when we solve it using the, so back up again. So we get a rounded value when we use the bisecting chord up here, so the perpendicular to a chord theorem, whereas on this one, we're still using the idea that we have a chord that's been bisected, but we're using the Pythagorean theorem. We get an even number. So which one do you use? On the test, using either method will give you the correct answer. So it won't matter on the test. Point Y is the center of a circle, and XZ is the diameter of the circle. Okay, so they do not give you a picture. You have to draw this in. I put this in for the review. Again, they do not give you this picture. They do not draw any of this for you. You have to draw it for yourself. So point Y is the center of the circle, Y. And XZ is the diameter of the circle. So if XZ is the diameter, that means that I can go like this. Clearly my Y needs to be in the center. And I have XZ. Point W is a point on the circle different than X and Z. So point W, so W could be here, it could be here, or here, or here, or here. Okay, so we don't really know. So we need to evaluate the statements. So the measure, switch colors, let's see, the measure of, okay, evaluate the statements below and mark if they are always true, sometimes or true or never true. So the measure of X, Y, W, so X, Y, W is 2 times greater than the measure of z, so ZYW. So say it looks like this, and we're saying that that this is like 2 times this. And it's not true the way it's set up, but if we chose another angle around here, it could be. We don't know. So that's sometimes true. Okay. So let's see. So I could actually show another version. So if it was XY, so say it was XYW, like we were going to look at this, we're going to use this angle, is that 2 times ZYW. And in this picture, you can see it would be. So not and then would be. So that's why it's sometimes true. Next is ZYW. Okay, that's this angle here. Is that 1/2 ZXW. Okay. So, well, ZXW, this angle here, that's an inscribed angle. ZXW is an inscribed angle. This is an inscribed angle because you have your endpoint on a circle and 2 chords, and then you have Z, okay, and then ZYW. So we're comparing a central angle to its inscribed angle. So this, the inscribed angle is half as much. So ZYW should be, this should be twice as much, 2 times as much as this, right? So this is wrong. This should be 2. So this is never true. XW is greater than XZ. There's a typo on this. What they want us to, what we should have been comparing, what I need to fix on your review is XW. So XW, some distance. And we don't know if this is an arc because the test doesn't tell you, or if this is, we don't know if it's an arc or if it's just a segment, but it doesn't really matter. If it's greater than ZW. So is XW greater than ZW? So if I were to draw this in like this, so is this distance greater than this distance? Well, not in this picture, but if I did another picture where it was like this XW to this ZW, then yes it is. So sometimes. And is, oh, looks like we have another typo. So this should say the measure of ZYW is at 90 degrees. Well, it could be. Okay, almost done with this topic. This question still refers to this picture, but I'm going to draw it out. So this is Y. We know down here we have our diameter. This is X, and this is Z. And it says if YW X, so I want this to be pretty small. This is W, so YWX. Okay, if this is equal to 35, then what is the measure of ZYW? So I want to know what this measure is here. Okay, so if this is 35 here, this is the radius, this is 35, this is the radius, that means this also has to be 35 because we have an isosceles triangle. If this is the radius, this is the radius, this angle has to be the same as this base angle, right? So 35 and 35. So these are congruent, which means we can solve for this third one because we know this is a triangle. We know this second side, the third angle. Well, I don't need a calculator. 35 and 35 is 70. That means that this last part, this has to be, clearly my triangle is not drawn to scale. This would have to be 110 in here. 110 right here, which means the supplement to that would be 70. So Z, Y, W is 70 degrees. So in other words, this exterior angle here will always be double what this angle is here. Determine the measure of PML, so this, in the circle below, or LMP. Okay, they're asking for the same thing. Okay, so first thing is we want the measure of QK. So QK is this arc here. Okay, and we can use the same thing we used on, let's see, problem number 12 up here, the same idea. Okay, so this arc length minus this arc length equals this angle. So 60 minus, I don't know, what am I call this? I guess I'll just call it QK divided by 2 equals 19. Multiply both sides by 2. So I get 60 minus QK is equal to 19 times 2 is 38. So let's see. Alright, and then I need to subtract 60 minus 60, so I get negative QK is equal to, it's going to be negative, let's see, 22. So QK equals 22. Good. And let's see. Let me make sure, get my calculator, make sure I do this right. Right. So 60 minus QK equals the arc, so we want to multiply both sides by 2, so 19 times 2 is 38, got that right, and then I have to subtract, so 38, let's see, minus 60 is 22, so I have 22. So this little bit here, this little arc is 22 degrees. And then I want to know LMP, or they said PML, so that's this one right here. Let's switch colors. So, oops, sorry, I'm getting off the screen. Okay, that's this right here. So if I know that this right here is 22 by my earlier part of the problem, this is 22, then I also know I have, I'm coming back up to this problem, oh, where is it? This problem up here. Nope, no, it's not that problem right there. Never mind, scratch that. Okay, so what it is it's, we take this one, so we go, we're going to take this arc, we're going to add this arc, and we're going to divide by 2. That comes from your topic 1. Topic 1, you saw it right here. So it's page, what page is it? Oh, page, I have no idea. Mine aren't marked. Anyway, this is the picture right here. So to find the length of these angles, you add this one and divide by 2. The formula is right here. Okay? So, and you see a lot of examples. The examples came from arcs and inscribed angles in part 2, okay, where you add this one, and you add this one, and you divide by 2, or multiply by 1/2, and that gives you the answer. So that's what we're going to do for this part. So now that we know that this is 22, I have 54 plus 22 divided by 2. So that's 76 divided by 2, which equals 35, 36, 37, 38, right? 76 divided by 2 is 38. Yeah. So that's 38 degrees. And also QMK would be 38 degrees. Right. you need to be really careful on this last problem, number 18. We have a picture here, and it looks like O is the center, but O is not necessarily the center. There's nothing that tells you that O is the center. So you do not want to make assumptions based on O, this is O, being the center of the circle, okay? Consider the circle to the left. And there's also a value out here. How do we, what do we think about this? Well, if O is the center, then if this is 88, this would also be 88. So that tells us it's not the center. But you need to be very careful not to make assumptions based on the fact that this is the center of the circle. Which of the following statements are correct? Select all that apply. Please select all that apply. Here we go. So if this is 88, what we do know is these are supplementary. So this would be 92 in here. 92 for your other angle. And that would be 88 here, and this would be 92. So we know that so far. We also know that if this is 97, then this is an inscribed angle here. If this is 97, we can calculate this little bit here. So we can take 97 and divide it by 2, and 97 divided by 2 is 48.5. So this is 40 here, this is 48.5. Okay? The same thing here. If this is 97, this is 48.5. Okay? Which means you can calculate the third part. And we know this. We know that if you have an arc intercepted, okay, that these are congruent. These tips here are congruent, and this tip is congruent with this tip. So we want to find the third angle here. So the third angle is 48.5 plus 92. That equals 140.5. And we're going to subtract that from 180 minus 140.5, and that equals 39.5. So this is 39.5. This right here is 39.5. Okay? And you can just check that again. And it equals 180. So both triangles equal 180. Okay. So I've kind of filled in the information I need. Let's see, anything else I can fill in? This is 39.5. I can figure out what this arc is here. So 39.5. If this is the tip of my ice cream cone, then my ice cream would be 79. So this is 79 here. This is 97. And so I can figure out what this is and what this is, right? These lengths. So I know that this length plus this length must be less 360. So 97 plus 79 is equal to 176. So this one plus this one is equal to 176. And if you subtract that from 360, you get 184. Okay, so this plus this equals 184. And that's pretty much where we're going to go from here. So here we go. WOX, the measurement of that angle equals 92. 92, not 76. The measure of the arc of WY, so WY is 92. 92, no, it's 79. Okay. Not so many so far. So WOX is similar. So WOX is similar, we would have to say, to YOZ. No, you say YZO. That's not the same order. We want these to be in the same order if you're going to say that the two triangles are similar. So we would have wanted to say WOX is similar. WOX is similar to YOZ. Okay? WX. So WX, the measure of WX is 92. It's only 92 if it's a central angle, right? So is this a central angle? We don't know. What we do know is that we can figure out what these two together equal, right? So we know that 79 plus 97 is equal to 176. So if you subtract 360 from 176, you get 184. So this one and this one have to share 184. And if they're 184, then this is equal to 92. So we'll go ahead and we can say that this here together is 92. Okay? Assuming they're congruent. All right? And then is the measure of WX. So the arc of WX, that's this one plus this one, 176. That is. All right, so that finishes us up for this review. The last question says, know the steps for constructing the inscribed circle to QRS and an inscribed and a circumscribed circle to QRS. I said that's topic 9. I've told my students, but you need to find your topic 9 in your workbook. And I'll show you. You need to memorize how to inscribe and circumscribe a triangle. So if I can turn the page. You need to know these steps here. So constructing inscribed, let's back out of here. So constructing inscribed circles and constructing circumscribed circles with a triangle. Okay, so you need to memorize that. I don't know what page that's on, but it's in topic 9. Otherwise, good luck.